Hey everyone! Welcome to the Expressify Vibes. Our mission is to be the go-to destination for tech enthusiasts. We aim to elevate your tech journey by providing engaging and practical insights, making each visit an opportunity to learn and be inspired. In this video, we'll delve into the diverse state management techniques available for your React application. React inherently provides several techniques for managing state, each with its own applicability and trade-offs, which we'll explore in detail. Additionally, we'll introduce Zustand, a state management library, and discuss how your state management needs evolve as your application grows in complexity. Let's get started by exploring some inherent state management techniques offered by React. Local state management with a useState hook. The useState hook is used to add local state to functional components. This hook returns a state variable and a function to update it. It's ideal for managing state that is local to a single component. Here is an example to demonstrate the usage of a local state variable. The counter component has a state variable called count. There are 3 buttons that are displayed which handle 3 separate operations called increment, decrement, and reset. On button click, a handle click callback is invoked, which processes the operation and updates the state variable. As you can see, this is a very simple example that explains the usage of state variables that are local to a single component. The React Context API. The Context API allows you to create a shared state that can be shared across multiple components without having to pass props down through the component tree. It's useful for managing themes, user settings, authentication data, and other data that are required to be accessed across a hierarchy of components. Let's look at an example of Context API with useState. Let's try to rewrite the previous example using the React Context API. The first step requires us to define the shape of the context data. As we already know, we have a count variable followed by 3 operations: increment, decrement, and reset. React exposes a createContext function that allows you to create your context. So we create the counter context by passing in the default context value into the createContext function. The next step is to define the provider. In this case, the counter provider uses a state variable and exposes the implementation required for increment, decrement, and reset. In line 21 here, you can see that the provider exposes not just the value of the count, but also the functions to increment, decrement, and reset. Now that we have defined our provider, let's look at how to consume this information in our component. The most important step here is to make sure that this provider wraps the consuming component. Inside this app component, you can see that the counter component is wrapped by the provider. The cool thing about the Context API is all components that are wrapped by this provider have access to the context data. The counter component looks much simplified now. React exposes a special hook called useContext to access the information inside the shared state. Now you can see that the button clicks are directly invoking the increment, decrement, and reset functions exposed by our shared state. The useReducer hook. The useReducer hook is used for managing more complex state logic in functional components. It's very similar to useState, but provides more control over how the state is updated. It's particularly useful when the next state depends on the previous state or when the state logic is complex. It pairs really well with the Context API for more extensive state management across a large component tree. It allows you to handle the application state through a reducer function and an initial state. Let's look at an example. Using our previous example, the first step would be to define a reducer function. A reducer function is a pure function, meaning it always has a deterministic output. The output of the function is determined solely by its input values, and given the same input value, a pure function always returns the same output. And secondly, this reducer function has no side effects. It does not modify any external variables or make network requests. Given the state and the action to perform, it interprets the action type and updates the state variable, in this case the count. If it does not recognize a specific action type, it throws an error. We start with an initial state where our count is set to 0. Now let's look at how we would rewrite the counter component. React exposes a special hook called useReducer that accepts the reducer function and the initial state as inputs, and provides a handle on the current state and the dispatch function. The next simple step is to just rewire our button clicks to use the dispatch function and set the right action type for increment, decrement, and reset. How simple is that? While these inbuilt solutions might work for most cases, they come with their own trade-offs. Both the useState and useReducer hooks are highly performant for local state management. However, they don't inherently provide a global state solution for large applications where the state is shared across many parts of the application. Similarly, the Context API works well for small to medium-scale applications. However, it can lead to unnecessary re-renders in large applications, since any change in context value triggers re-renders in all consuming components, regardless of whether they use that part of the context. Using a state management library like Zustand in your React application can offer several benefits that lends itself to easier management of global state. Zustand is known for its simple and minimal API. This makes it easy to learn and integrate into your project. It does not enforce strict architectural patterns, giving you the flexibility to structure your state management as you see fit. Zustand uses a subscription-based model, which can lead to more optimized renders compared to some other state management libraries. It updates components that subscribe to specific pieces of the state only when those pieces change. It reduces the boilerplate code often associated with state management in React, particularly when compared to more verbose libraries like Redux. Let's look at an example to integrate Zustand store into your React application. The first step is to include Zustand as a dependency in your application. Here, I'm using the latest version of the library. In Zustand, the create function is used to create a store. The argument to the create function is also a function. This function will receive a set method and a get method optionally as its argument. The set function is used to update the store state, as you can see here. The get function is used to get the current state. We will see an example with the get function later in this video. This function should return an object. The properties of this object represent the initial state of your store and any methods for updating the state. In this example, create is the function from Zustand to create the store. The store setup function is here, like I mentioned before. Count is a piece of the state. Increment, decrement, and reset are actions that update the state. Now let's look at our counter component. The store is a hook. We don't need any providers. We simply extract the piece of the state and the actions and use it in our component. This pattern allows you to manage global state in a very flexible and straightforward way, fitting various use cases in React applications. Before we explore other capabilities with Zustand, let's switch our counter example with another component that truly represents a realistic use case. We now have a products list component that has a state variable to store a list of products. It makes an asynchronous call to query the products and updates the state variable on mount. It then renders a list of products displaying their name and price. Currently, products is local to this component. Let's see how we can use a Zustand store to make products shareable globally. Let's set up a Zustand store to manage our list of products. Our product type has attributes like ID, name, and price. Our state has a products list and a setter function to update the products. This is very similar to the counter example, where we now have a list of products instead of a numerical count. Now that we have our store, let's look at our products list component. You can see that the useStore hook looks slightly different from our previous usage, which has been commented out at the top. This approach, using multiple useStore calls, allows you to select individual pieces of the state. By selecting only the specific pieces of state a component needs, you ensure that the component only re-renders when those specific pieces of state change. This can be more efficient than subscribing to the entire store, especially in larger applications where different components might be interested in different parts of the store's state. While selective rendering is generally good for performance, be aware that each useStore hook creates a separate subscription to the store. In scenarios where you have many state slices being selected in a single component, this could theoretically lead to a slight performance overhead due to multiple subscriptions. However, in most cases, this overhead is negligible and should not be a major concern. If you have a mix of components in your application, some using a single useStore call and others using multiple, it could lead to inconsistencies in how state is accessed. It's often beneficial to establish a consistent pattern for accessing state across your application. Now, when the API call succeeds, we directly update the products in the store, which is made available to other components in your application. Can we simplify this further? What if we are able to query the products within the store itself? It turns out that Zustand supports asynchronous actions to make this possible. Our updated store now has fetch products, which is an async function. The backend API is invoked here to query the list of products. The get function that we talked about earlier is used to access the current state to allow us to call set products. What if we simplify this further? We can actually remove set products from our state and directly use the set function to update the state. So instead of doing this, we do this, which is the same as the implementation for set products. All the consuming components would always get the updated list of products from the store. So let's go back to our products list. We can see that onMount fetch products is invoked, allowing all the magic to be done behind the scenes and providing the updated list of products to this component. Creation of multiple stores. You can have multiple Zustand stores in your React application. Zustand is flexible and unopinionated, allowing you to create as many stores as you need. This can be useful for organizing your application state in a way that is logical and manageable, especially as your application grows in complexity. Some benefits include 1. Modularity. Different aspects of your application state can be managed independently. For example, you could have separate stores for user authentication, application settings, and other domain-specific data. The second benefit is maintainability. Smaller focused stores can be easier to maintain and understand than a single large store, especially in large applications. The third benefit is separation of concerns. Different stores can encapsulate different areas of functionality, aligning with the principle of separation of concerns. One important caveat to note is that while multiple stores can help organize state logically, they also introduce additional complexity in terms of managing and connecting these stores. If not managed carefully, having multiple stores can lead to performance bottlenecks, especially if there are dependencies or frequent synchronizations required between stores. To recap, we started this video by looking at inherent React patterns for state management. Firstly, we looked at useState, which is great for local state management within a component. The context API works well to avoid prop drilling, where the components pass multiple props through a component tree, but can lead to performance issues for large applications with unnecessary re-rendering of components. useReducer can be a good solution when you need more fine-tuned control over your state changes and is sometimes used with the context API. It might require more boilerplate code to define the reducer function depending on how complex your use cases are. Zustand is a lightweight, simple, and flexible solution for global or more complex state management. When done right, it can be extremely performant. Your applications may also have multiple small-sized stores that work independently, serving diverse feature sets. In conclusion, each of these techniques has its use cases and can be chosen based on the complexity and requirements of your React application. As with any programming approach, it is important to understand their benefits and trade-offs and use them wisely to optimize for efficient and maintainable code. Thank you for watching this video.